Hello and welcome back to the channel. Today's video we're going to be introducing the ACT Science section. Go over what to expect, our strategy for it, and how to prepare. As always, if you find it helpful, leave a like, subscribe if you want to help the channel, so you want to post new videos or help others find the channel, and comment with any questions you might have, something you might want to see more of, or things that you like so I can make sure I can do more of that. But let's begin with some things to know first. So, the big thing for science now, I am recording this after the 2025 ACT changes. The science section is now optional. So, we're going to have to look and see how this plays out to decide should we take it or should we not. But my general advice, first and foremost, look at the colleges that you're interested in and look up their requirements, especially for your specific programs you're interested in. Certain colleges might require science. They might require science just for scientific or engineering degrees. So obviously if any of these things are requiring it, you should take it. So start there. If they don't require it, then you need to think about doing some more research. And I've covered this in some of the other videos as well. But look into the statistics for those schools to have an idea of what have their students generally done in the past. Which obviously if this is just brand new, you're not going to have that yet. So they're going to be figuring out too. You could also try calling or contacting their admissions. You can talk with your guidance counselor. But if you just want a general rule of thumb, if you are interested in an engineering, math, or science degree, I would recommend taking the science section if you can do well. If you are not interested in one of those degrees, then I would try it out, do a little bit of studying depending on how much time you have to prepare. If you have just no time to prepare for the ACT, do a quick practice test, see how you do on the science. If you can do well or have time to do well, it can only help you stand out over others. But if it's something that you just really struggle with and you don't have time to try and get better and you're just not even closely related to a scientific degree, then you might be better off not taking it. But at the end of the day, this is up to you and something you're going to have to make up your mind on based on what information is available to you and exactly what you're trying to apply for. So next, the cool thing about the science section is, despite the name, it hardly actually tests your science knowledge. It does a little bit. That's one of the changes now. It used to barely do it. Now you are going to get a little bit more. So what are you going to get? Instead, it's mostly going to test your ability to read graphs and tables. Not so much knowing the science behind them, but just knowing how to read them. As far as those that do test the science knowledge, you're going to get, at most, maybe one question per passage on scientific knowledge. So overall, you should expect somewhere between maybe 4 and 7 of these questions. So it's not nothing, so you still do want to study these, but generally, because there's so many different concepts that they could be testing and there's such a small amount of the test, it's one of the last things I would recommend studying, just general science concepts. Do go and look at multiple different sources to try and collect all of the different possible concepts that they might test. I have videos on some of the most common ones, but by no means do I cover absolutely everything. I will try to add to it as I go, but even so, look in multiple sources if you can. That's just the smart way to do it. Now, of all these passages that you're going to see with all the graphs and tables, there is going to be one that's text only. Sometimes it might have a graph associated with it, but typically it's just text. And for those, it's just going to have a few different scientists or students all giving their explanation about something, and then you are going to have questions that are going to compare and contrast their explanations. It's not about who is right, it's about being able to find and understand each person's argument. Another thing that, just like math, the science section does get harder as it goes. Reading and English do not, but math and science do. So anything pacing, do keep in mind, try and go faster earlier on if you can, because then you'll have more time towards the end. But just don't go so fast that now you're missing the easy questions, because that's not worth it. Next up, this is just the most intimidating section for most people. So don't be afraid when you get to it. You do your practice tests, and the score is just a lot lower than you're expecting. So that's actually usually what happens. Once you get the hang of it, which might take some practice, then you're going to see those improvements. You might see a sudden jump and then steady improvement from there, but it can take a while to get to that point. So just don't be afraid when you see it. Don't be afraid when you notice that your score is not what you think the first time you try it. You're not the only person. Now, just like reading comp, the experience with the science section is going to be key to success. It's not all about studying the science concepts. It's about taking the science practice tests. If nothing else, take a whole bunch of them, because it's learning what it looks like, how to read their graphs, how to handle their questions. The last thing I wanted to talk about on this slide is that this is the last section, unless of course you're taking the writing section, which is also optional. So because it's so close to the end, fatigue is often an issue for this section way more than the previous sections. So once you get the hang of it, you might actually want to practice this section while fatigued, and I'll cover that a little bit more later. But you will find that your scores when you're just practicing science might be higher than when you go and actually take the whole test, and suddenly your science is a much lower score. It's often because you're just tired by the time you get there, and so you're not focusing and you're making small mistakes, or maybe you can't go as quickly. So you can practice to try and deal with that. So what should you expect from the science section? You'll have 7 passages, roughly 1 page of text and graphs and tables, and then you're going to have 5 to 6 questions for each passage. As I said on the previous slide, maybe one of those will actually be testing your scientific knowledge. The rest are just reading those graphs and tables. And as I mentioned before, one of them is going to be text only. So this one passage is going to be a lot more like reading comprehension, but it's going to be focused on finding details and similarities and differences between all their arguments, not about the scientific knowledge, except maybe they might have that one question. And overall, you're going to have 40 minutes to answer 40 questions. So that's a pretty easy 1 minute per question. But keep in mind, you also have to at least skim the text and graph and tables. I'll cover exactly what you want to do there. I don't recommend that you thoroughly read the passages before you get to the questions. Now, of those 40 questions, 6 of them, or one passage, you won't know which one, is going to be experimental. These are not going to count towards your score, and you're not going to know which ones those are. So the main strategy here is don't waste too much time on any one passage or any one question, because it might be one that doesn't count at all. Now, one thing we can keep in mind, I can't guarantee it, but would make sense to me, they have said you will always have 6 questions that are experimental in science, and they also said any of the passage-based ones, so same with reading or English, they're going to be clumped, all the experimental ones, so it's one whole passage that's experimental. Well, if some of the passages have 5 questions and some have 6, all the ones with 5 then are going to count. They can't be one of these because you need to have 6 to be experimental. So if you are trying to debate, I only have so much time left, should I be focusing my time on these last few questions of a 6-question passage or these last few questions of a 5-question passage? Maybe focus on the 5 because that one's more likely to be one that's counting. So some general advice for practicing science: start small. As I said, it's going to be pretty tough at first for most people. So start with just a few of the first passages. And those are the easy ones, because remember, it gets harder as you go. So as you get used to those easier ones, start working your way up until eventually you're doing a whole science section. Now, if you are struggling with both pacing, as a lot of people do, and also just how do I do this? How do I handle these types of questions? Which is common. We normally have both of these issues. You can consider in your practice, not the real test obviously, but in your practice using what I call a double take method. So that is where you take the test or the passages, depending on which way you're doing it, twice. Which sounds annoying, but the way you'll do it is the first time you take it, time it and treat it just like you would the real test, because you want to practice good habits first, where you're actually watching the time, and you want that to be representative of you actually never having seen the questions before at all, because that's how it's going to work in the real test. But then, after you've taken it that one time, doing it properly, go back, take it again, but this time, take all the time you need to find the answers. This is all about just learning that how do I answer these questions? What did they actually want me to do? And as you start to figure these out and realize, oh, this is how the science section works, you can start cutting this second practice out. Just take it the one time, but it could be really helpful at first to actually figure out what is even going on with the science. Now, don't bother checking your answers until you've completed both attempts if you're trying this, because again, when you go back and try this again, taking all the time you need, you really want to still practice, how can I get to this answer and solve it myself? If you already know the answer, you're going to skip some of the things, or you might not catch or practice at least thinking through them. That's the main thing. So after you've taken both attempts, then go and see how you did. So this method is just going to let you get more comfortable with the section in the second take, as I've said before, but it prevents you from practicing the bad habits and forgetting the correct pace. Speaking of pacing, let's cover that. So because they've changed it now to 40 questions in 40 minutes, it's very easy. Just count the number of questions in the passage. That's how many minutes you want to aim for on the passage. So 5-question passage, you want to do 5 minutes. 6-question passage, you want to do 6 minutes. Now just remember though that the passages do get harder as you go, so try to use less time early on. That way you'll have more time later on for the harder ones. And finally, do not read the passages in depth. Ideally, you want to spend under 2 minutes actually reading these passages. If anything, try to go even less, 1 to 1.5. Because we now have 7 passages instead of where it used to be 6. So you really want to focus on spending most of that time on the actual questions themselves. So how do we handle this? Again, don't read the passage in depth. You're just going to skim it for a rough idea of what the experiment is, and then search for a few key things. Those would be definitions, and that's where it will actually define terms for you in the text. It's important to know where those are in case there's a question about it, or if a question involves those terms where you actually kind of have to know what they're talking about, then you can come back and actually try to figure out what those definitions mean. You don't need to actually read those definitions in your initial skim because it might not matter at all, but know where they are in case you do have to come back to it. Similarly, you're going to look for the experiment description. So what is the experiment doing? You can skim through that. You don't have to fully understand the experiment most of the time, but again, there might be a question about that, and you'll just have to know where to find it. The more important thing to do is to identify the variables and the controls. Variables being the things that they are testing, things that they are changing. So as a random example, let's say they're trying to figure out, do carrots improve vision? So they're going to try giving a bunch of people different amounts of carrots. The variable here would be how many carrots do you get? The other variable would be some measure of your vision. So those are things they are changing and things they are measuring. A control, any good experiment will always have a control group, which is basically going to have the nothing of whatever you're testing, or some baseline to compare against. So in the case of the carrots, that would be someone that was given no carrots. The next and probably most important thing in here would be variables in the graphs and the tables. Again, you're not trying to fully break down the data and know what it's telling you. You just need to know what information is in each table. So when they have a question asking you to look up something, you know I'm going to go to this graph or this table because that's where these variables are involved. Focus your time on the questions, not the reading. All of this, again, should take under 2 minutes. And I wouldn't recommend it, but if you get really good at it, you could even get to the point where you just don't read anything and you go straight to the questions. Once you're really good at knowing how to find things and you know how they generally structure their science sections. Typically, it's still better to do a skim, but for some people, after a while, they have been able to just go straight to the questions. So you can try that if you need to, but I wouldn't recommend it, especially not early on. As you do get to the questions, break them down as you go. And I'll cover what I mean by that in another slide here, but it's going to sound a little redundant and it'll feel like it's slowing you down, but it's actually going to just be a way of slowly and methodically narrowing down the passage and the graphs to find what they're actually asking you to look for. And you'll kind of have your answer then by the time you reach the end of the question. And we're going to look out for some key question types. Those can be identified actually by what form the answers take. I'm going to cover that and how to break down the various types of graphs in my next video. So the variables. Like I said, the most important thing back there is to just know what are the variables in each graph and table. So for each graph, you're just going to look at the x-axis. That's the horizontal one at the bottom. And the y-axis variable. That's the vertical one on the left, or right if there's two y-axes. Do look out for that and know what they both are. And again, my next video will go over how to read that properly. If there are several lines on that graph and not just one, look at the legend or the key that's going to tell you what each of those lines is. That way you know which line to read. And if you're not sure what that really means, again, that will be in my next video. If you have several graphs and they have the exact same variables, because again, the whole point is to know which graph am I going to go to, but if they have the same variables, how do I know which one to go to? In that case, you will need to skim through the wording to figure out what is the difference in the experiment for each graph, because that means they're changing something. Then for the tables, it's going to be the same idea, but in this case, I just need to know what are the columns and what are the rows. Because again, I don't need to know exactly what the data is telling me, I just have to know which table should I look at, which graph should I look at, depending on the question. So I mentioned earlier that we're going to break down the questions as we read them. So let's talk about what I mean by that. We are going to read the questions, and as you read, stop. Whenever you get to a new piece of information that's going to narrow down where to look, either in the text of the passage or in a figure or table, or it might give you a couple different options. Whenever you do get to that new information, stop and find that spot, either in the text, figure, table, and then you can go back to your question and keep reading until you get to the next piece of information that will narrow it down further. And you'll rinse and repeat, and you'll slowly work your way through the question. I'll give you an example here in a second. This is going to feel very unnatural at first, so you definitely want to practice and get used to it. But it's really important for a couple reasons. First of all, you're just going to narrow down and slowly get to your answer as you read the question, and by the time you're done reading it, you're going to have your answer for the most part. The other and most important reason is I talked about one of the big things with science is fatigue. It's at the end of a very long test, you're tired. This is really where people make mistakes. One of the main ones would be something like if it tells you, go find something in experiment 1, and they have 2 or 3 experiments, very common mistake is someone will go and find the right thing, but they're going to find it in experiment 2. And then they get it all wrong, even though they know what they're doing, they're just tired, and they went to the wrong section because they were just absorbing too much information at once. If you break it down as you go and get used to it, you're really just doing one thing at a time, and you're less likely to make those mistakes. So let's take a look at an example here, and then we'll solve it on the next slide. So I'm going to read this, and I'm going to pop up some highlights as to what I consider to be the information that would be important. So we'll start here. Consider the height measured. It's the first thing I'm going to highlight, because that tells me I need to go to anywhere in a table or a figure that's measuring height. I don't care about any other variable now. I'm just going to go find height. Once I see everywhere that has height, I come back to the question and keep reading. So consider the height measured in experiment 1. That's the next thing. Now I know I'm going just to experiment 1. All the other experiments, I don't care about them anymore. I'm going to go to experiment 1 and just look at that height measured. Then I come back to the question. For beans. So this might not matter if it's the only thing being discussed, but I'm going to highlight it because if there's different things, say beans, carrots, tomatoes, I need to find out which one is just beans. Once I see that in experiment 1, I come back to my question at 400 mils per week. This is my next bit. So now that I know I'm looking for height in experiment 1, just for whichever one means beans, I'm going to find the 400 mils per week part of that graph. So that's the first sentence. I now have a specific spot. I'll keep reading. The same height, so whatever height I just found so far, I'm going to go find that same height somewhere else. So I might stay on the same figure and move off of beans, or I might go to a different figure, but I just need to make sure I find somewhere else that also has height, and I need to find that exact same line or number. So I'll come back to my question. That same height was observed for beans, so I still care about beans, nothing else. In experiment 2, alright, so that's what changed. So where I was in experiment 1 and I got a number, now I'm going to take this over to experiment 2, still beans, and find that same height. And I'll keep reading. With what amount of fertilizer? Okay, so I had this height for beans, now I'm in experiment 2. Now I need to go and figure out, alright, what's the amount of fertilizer at that point? And now I'll be at my answer. So there's a lot of things, and as you saw, it's really choppy. So it's going to take some getting used to. But again, while it feels unnecessary, especially if you're used to this kind of stuff and you're fresh to it, try it again when you're dead tired or even doing a test for hours, and you'll find it's very helpful. So let's go and actually solve this one with the figures, so it's a little easier to find and see how to do this. So let's begin. Consider the height measured. So I have experiment 1 and 2 here. Height, I'm going to find it. Height is my y-axis for both of these. So I don't know which graph I'm looking at yet, but I do know I'm starting out by looking at the y-axis. Back to the question, measured in experiment 1, so I can ignore experiment 2 over here. I'm only looking over here and considering the y-axis. For beans, okay? Well, if I look at this, the dotted line with the squares, those are beans, whereas the solid line with the dots, those are tomatoes. I don't care about the tomatoes, so I only want to look at this dotted line here, and I care about the height. So for the beans, at 400 mils per week. Okay, where do I see mils per week? That's here. Here's 400. So if I go at 400 to the dotted line with the squares, because I know I care about beans, and I want to consider the height. Well, what is the height here? It's in between 11 and 12, or 11 and 13. So at the halfway point, it's 12. They're never going to really have you do like some 12.2 versus 11.8. If it's in the middle, it's in the middle. They're not trying to trick you there. So from this part, the height measured for all this stuff is 12. Now I can keep reading. The same height, okay, so now I need to keep that in mind. I just found 12. I'm going to find that 12 again, either here or here, was observed for beans, so I still care about beans, so with either of these, it's still just the dotted line. I don't need to worry about these solid lines. In experiment 2. All right, so now I'm in experiment 2. That same height was 12, so I'm right here. Anything on this horizontal line, which, hey, I got lucky. This is where they intersect. So I can already tell you I'm at this point. So that same height was observed for beans in experiment 2 with what amount of fertilizer? Where's the amount of fertilizer? That's my new x. So I was at this point. Come down. It's 5. So that's what I mean when I say we're going to break down the question as we read it, and you're just going to have the answer naturally. And that'll prevent you from accidentally reading these backwards and starting with experiment 2, or accidentally reading tomatoes. Those are very common mistakes. Now let's talk about that text-only section, because everything I just talked about is how to break down things with graphs. What if they're not there? So unlike the rest of the passages, this one you're actually going to have to read. So that whole skim in 2 minutes might be harder to do. You might need to bump that up closer to 3. Again, that's going to vary a bit from person to person. There's going to be 1 to 4 people in that passage, usually students or scientists, but that doesn't really matter. Each of them are going to give some explanation for an experiment or a concept, some theory. Again, you're not worried about the science. You just need to know what they're actually saying, what those details are, where they are the same, where they're different. So you're going to find 2 things, which I just kind of told you. Definitions, just like before. So if they have a question about something, you'll know where it's defined. And then any specific points where they agree or disagree. So if you see the same point in multiple scientists, then underline it. If you see them talk about something similar, but they give a different reason, that would be a disagreement, underline it. That's going to be the basis for most of the questions in this section. So if you know where they are, then you'll be good to go, and you'll be able to find them and answer your questions. So for those questions, always base your answer on the text in the passage. So don't go from memory, because there's several different answers being given by different scientists or students, so you can easily mix them up. Do not try and go from memory. Go find it. And definitely don't go from your own scientific knowledge. Because while you might, if it asks, well, student 4 said, what is the boiling point of water? If you know the boiling point of water, you might be tempted to say, oh, it's this, and just circle that answer. I don't know if that's what student 4 said. So go back and check. All right, make sure that you read the correct student or scientist explanation. There's going to be multiple of them. Like I said, the most common mistakes in science are just misreading things. You might be going to the wrong experiment. In this case, it's usually they ask about scientist 4 and you gave the answer from scientist 3. So if they ask about student 3, only read student 3's explanation. Don't go and start comparing it to everything else if they didn't ask about anyone else. Keep in mind that only one of them is actually correct, scientifically speaking. While that doesn't matter as far as you knowing what's right or wrong, what comes into play is that they might ask you, kind of like that boiling watering I was talking about, they might ask you what the boiling point of water is according to scientist 4. If scientist 4 said it's 50 degrees, which is wrong, the answer is 50 degrees. So don't go with your own knowledge of what is scientifically correct. Make sure you base it on what that student or scientist said. Sometimes I might even ask you to create a graph based on someone's explanation, and that's where that'll really get people. Because they'll often go like, oh yeah, I know the graph should look like this. Well, if that student's explanation was wrong, then that answer might be scientifically incorrect, but it would still be the correct answer. So that takes a little getting used to because it's backwards, but read carefully and watch out for that. So base your answer only on the specified student and you're going to be fine. Now, that fatigue problem I was talking about, it's the last section, so you're going to get tired, and that's going to hit people different ways. So some people are going to be fine with it, others are going to be hit a little. I've seen some massive score drops once we switch to whole tests for my students, for some people that just really get tired and it hits them. So you might not even notice it. You might think you're fine, but then you go and actually score it and realize you made a lot of silly mistakes. Lots of times that's reading the wrong graph, reading the wrong line. That's where breaking down the question helps a lot. So don't worry about it at first. Begin with just learn how to handle the science section by itself. No need to work on the fatigue and that stamina until you actually have an understanding of how to handle the science section in ideal conditions. But once you are comfortable with the science section, try taking a whole practice test, not just science, but the entire thing in one sitting. And then see if your science score is lower than usual. If so, that tells you that possibly it was just a harder test and you got unlucky, but most likely fatigue was hitting you. So if you do realize that fatigue is something you struggle with, here's how you can improve. And unfortunately, it's not fun. But the only way to get better with that fatigue is to train your brain just like you would train your body for a marathon where getting tired is a problem. So that means you have to practice the science section while fatigued. You can't train a marathon by just going out and doing sprints every day. You need to run long distances, and you need to eventually work your way up to an entire marathon. Same thing here. You have to actually practice doing the science while you're tired and pushing through it. So there's a few ways you can do that. One would be to take multiple ACT sections back to back and work your way up to doing full tests. Just make sure if you do this, always do them in the same order as the actual test. That way you get used to that, and for each one you have a more accurate representation of how tired you'll be at that point. So if you do an entire test, do them in this order. If you're starting out, maybe just do reading and then science. As you get better, do math, reading, and science, and then eventually do the whole thing. You could also just do 2 whole science sections back to back with no break. And that would be from 2 different tests, because obviously there's only one science per test. So that would be if you're really trying to crack down on science in particular, you're pretty good with the other sections, or you're just focusing in on science. So that way you get double the practice with science and one of them while fatigued. Another thing you can do that I often did with my students where, you don't always have time to go do an entire test is find a time where you're naturally fatigued. And that's really going to be something where you're going to have to sit down and think about it. So that could be right after you get home from school, right after you get home from sports after school, maybe right after some big test. Or it could be if you go on vacation, if you right when you get back from your flight, so you're jet lagged and tired. So maybe right after you do a lot of homework. So if you don't have a ton, maybe right when you get home from school, immediately do your homework, then go do a science section. Basically, the rule of thumb is whenever you really just do not want to practice the ACT because you're tired and just want to nap or do something fun, that's when you need to practice the science section. As I said, not fun, but it's the only way to get better about pushing through that fatigue. So keep that in mind and really try that out, and it will help over time. That'll do it for today. Next video will cover the different types of graphs, how to read them, and those specific, special, unique question types, where if you're able to identify them, you can take advantage of some tricks that'll help you get to your answer much more quickly and more accurately. So I'll see you on that one. Good luck.